Welcome to this introduction to stoichiometry. Stoichiometry is a fundamental concept in chemistry that helps us understand the quantitative relationships in chemical reactions. Today, we'll explore how to calculate the exact amounts of substances involved in chemical reactions, which is essential for both laboratory work and industrial applications. Stoichiometry is the study of quantitative relationships between reactants and products in chemical reactions. In simple terms, it answers the question, how much of each substance do we need, and how much will we get? This branch of chemistry allows us to predict the amounts of materials consumed and produced in any chemical reaction, making it invaluable for practical applications. Stoichiometry helps us answer two critical questions in chemistry. First, how much reactant do we need? This allows us to calculate the exact amounts of starting materials required for a reaction. Second, what yield can we expect? This helps us predict the quantities of products that will be formed. These calculations are essential for efficient use of resources and accurate experimental planning. Every stoichiometric calculation begins with a balanced chemical equation. Let's look at the formation of water as an example. Two molecules of hydrogen gas react with one molecule of oxygen gas to produce two molecules of water. The balanced equation is the foundation because it tells us the exact proportions in which substances react and form products. From our balanced equation, we can determine the mole ratios. The coefficients in the equation give us a ratio of 2 to 1 to 2. This means 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. These mole ratios are the key to all stoichiometric calculations, as they allow us to convert between different substances in a reaction. There are 4 essential steps for solving stoichiometry problems. Step 1, write the balanced chemical equation. Step 2, convert the given quantity to moles using molar mass. Step 3, use the mole ratio from the balanced equation to find the unknown number of moles. Step 4, convert moles back to the desired unit, such as grams or liters. Following these steps systematically will help you solve any stoichiometry problem. Let's work through a practical example. The question is, how many grams of water are produced when 4 grams of hydrogen react with excess oxygen? The term excess oxygen means we have more than enough oxygen, so hydrogen is our limiting reactant. We'll use our 4-step process to solve this problem. First, we write our balanced equation. 2 hydrogen plus oxygen produces 2 water. Next, we convert grams of hydrogen to moles. We take 4 grams of hydrogen and multiply by the conversion factor, 1 mole of hydrogen per 2 grams of hydrogen. The molar mass of hydrogen gas is 2 grams per mole. This calculation gives us 2 moles of hydrogen. Now we use the mole ratio to find moles of water. From our equation, 2 moles of hydrogen produce 2 moles of water. So 2 moles of hydrogen times the ratio of 2 moles water per 2 moles hydrogen equals 2 moles of water. Finally, we convert to grams. 2 moles of water times 18 grams per mole, which is the molar mass of water, gives us 36 grams of water as our final answer. Let's review the key points. Always start with a balanced chemical equation, as this provides the foundation for all calculations. Remember that moles are the bridge between different substances in a reaction. And finally, mole ratios come directly from the coefficients in your balanced equation. Master these concepts, and you'll be able to solve any stoichiometry problem confidently. Thank you for watching, and happy calculating.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.